Hello everyone, this is Prateeka from Canara College, Mangalore. I'm gonna present in front of you the introduction of coordination compounds and how to name the coordination compounds. So let's start. Coming to the introduction, firstly, what is coordination compound? Coordination compounds are the compounds which contain a complex part formed when a certain number of ions or neutral molecules are coordinately bonded to a central metal ion. Or coordination compounds are the compounds in which central metal atom is surrounded by ligands through coordination bond. Central metal atom is surrounded by ligands through coordination bond. Example, potassium hexacyanoferrate 2. Here, potassium is a counter ion, that is ionization sphere. Fe is a central metal ion and Cn minus is a ligand here. There are 6 ligands and coordination sphere is represented by the square bracket. Now what is coordination sphere? Coordination sphere is a part of coordination compound containing the central metal ion and the ligands coordinately bonded to it. That is, the coordination sphere is written within the square bracket and outside the square bracket is ionization sphere. Here in the example potassium hexacyanoferrate, we can see that coordination sphere is written in the square bracket and ionization sphere, that is K4 plus is written outside the square bracket. Next, what is coordination number? It is the number of coordinate bonds formed by the ligand with the central metal ion in a complex. It's a coordinate bond, number of coordinate bonds formed by the ligands with the central metal ion in a complex. For example, potassium hexacyanoferrate 2. In this complex, 6 coordinate bonds are formed by the ligand cyano with the central metal ion Fe plus 2. Therefore, coordination number is 6. Since there are 6 ligands, the coordination number is 6. Now, what is ligands? Ligands are ions or neutral molecules containing one or more donor atoms which form coordinate bond with the central metal atom or ion in a complex. For example, cyano, chloro, amine. Here cyano and chloro are negative ligand and amine is neutral ligand. Next one. Ligands are classified as monodentate, bidentate and polydentate based on the number of coordinate bonds formed by them with the central metal atom or ion. Example for monodentate are cyano, chloro, amine. Example for bidentate, oxalato. Example for polydentate, EDTA, that is ethylene diamine tetraacetate. Now, Iupac nomenclature of coordination compounds. Rules used here are: name of the cation is written first and then the name of the anion is written. For example, in the complex potassium hexacyanoferrate 2, while naming this complex, the name of K plus ion is written first, that is potassium, and then the name of coordination sphere is written because here potassium is cation and coordination sphere is anion. In the second example, the name of coordination sphere is written first because the coordination sphere is cation and ionization sphere is anion. Naming of complex part. While naming the complex, names of ligands are written first, then the name of central metal ion, and then the oxidation state of central metal ion indicated by the Roman numerals with the bracket without leaving any space between the names. Example, potassium hexacyanoferrate 2. Here, there is no space between the ligands or central metal ion or the oxidation state. Next, naming of ligands. Ligands are named alphabetically, that is in the alphabetical order. For example, in this complex, triamine dichloro-nitro-cobalt 4, the name of ligand are written in the order amine, chloro, nitro. If identical ligands are present, then the prefixes like di, tri, tetra, penta, etc. are used to indicate the number of ligands present. For example, in the complex, the names of ligands are written as triamine dichloro-nitro. Triamine because there are 3 amine and 2 fluoro, 1 nitro. Next one, if the ligand itself has its prefixes like di, tri, tetra, penta, etc., then the prefix used to indicate the number of ligands will be bis, tris, tetrakis, pentakis, etc. For example, in this complex, the name of the ligand is written as tris-ethylene diamine because in this ligand, di is mentioned. It's in the ligand itself. So we are using prefix like tris here. Next point, names of negative ligand end with O and names of positive ligand end with IUM. And names of neutral ligands have special names like aqua, carbonyl, nitrosyl, etc. Next one, naming of a metal ions, that is naming of the central metal ion. If the complex part is positive or neutral, the name of the metal is written same. And if the complex part is negative, the name of the metal ends with ATE. For example, in this first complex, the complex part, which is a coordination sphere, which is cation, which is positive, retains the central name of the central metal ion as a copper itself. And in the second example, here the complex is negative because it is an anion. So the name of the central metal atom will be ferrate. Next one, if bridging ligands are present, a prefix mu is used to indicate the bridging ligand. More than one identical bridging ligands are present, prefixes like dimu, trimu, etc. are used. Next one is, in the case of geometrical isomers, prefixes like cis is used before the name if identical ligands are present adjacent to each other. For example, here in this example, Cl is adjacent, whereas in the second structure, Cl is opposite. So the adjacent one is called as cis isomer and the opposite one is called as trans isomer. So the prefix trans is used if identical ligands are present opposite to each other. Prefix cis is used when identical ligands are present adjacent to each other. The prefix trans is used if ligands are present opposite to each other. In the case of optical isomers, a prefix D or plus is used before the names of dextrorotatory isomer and L or minus is used before the name of levorotatory isomers. Here, in the first structure, it is dextro because the substance rotates the plane of polarized light to the right, that is clockwise. It is said to be a dextrorotatory, the D or plus, and its mirror image, which rotates the plane of polarized light to the left, is levorotatory, that is L or minus. Again, with different charges are given here, and also name of the metal ion when the complex is negative is given only when the complex is negative. Ligand with -1 charge: chloro, bromo, iodo, nitrito N, nitrito O, nitrato, cyano C, cyano N, thiocyanato S, thiocyanato N, acetato, amido. Ligand with +1 charge: hydrogenium, nitrocilium, nitronium. Ligand with -2 charge: sulfato, carbonato, oxalato, imide ion. Ligand with neutral ligands, that is 0 charge: ethylene diamine, pyridine, triphenylphosphine. And neutral ligands with special names: aqua, amine, nitrosyl, carbonate. Now, the name of metal ion when the complex is negative, only when the complex is negative: copper, cuprate, zincate, aurate, argentate, cobaltate, chromate, nickelate, platinate, ferrate. If it is positive, the name is written the same, like copper, zinc. Now applying all the rules in these examples and writing the name of the coordination compound. In the first example, ionization sphere is cation and coordination sphere is anion. Hence, we have to write the name of the ionization sphere first and then the name of the coordination sphere. As per the rule, writing the name of the cation first and then the name of the anion. Hence, potassium is written first and then the name of a coordination sphere. As per the rule, while writing the name of the coordination sphere, name of the ligand is written first and then the name of the central metal ion and then the oxidation state of central metal ion. Since there are 6 cyano, we are writing it as hexacyano and then the name of a central metal ion, that is ferrate, and then oxidation state in the bracket in Roman numerals. Here ferrate because since the coordination sphere is anion, that is complex is negative, then the metal becomes ferrate. Metal ends with ATE. Now, how to find oxidation state? Now, taking ferrate as X plus -1 into 6, -1 because the charge of the ligand, that is cyano, is -1. Since there are 6 ligand, we are multiplying -1 into 6 +4 because the charge of potassium here is +4, then is equal to 0. X minus 2 is equal to 0, X is equal to 2. In the next example, here coordination sphere is cation and ionization sphere is anion. Hence, writing the name of the coordination sphere first and then the name of the ionization sphere. While writing the name of a coordination sphere, firstly we have to write the name of a ligand in alphabetical order and then the name of a central metal ion and then its oxidation state and then the ionization sphere. Here, pentaamine, chloro, cobalt 3 chloride. Pentaamine because there are 5 amine, 1 chloro and cobalt. Since the complex is positive, we are writing cobalt as it is and then writing the oxidation state of cobalt, that is 3 in Roman numerals in the bracket. then writing the anion. Finding the oxidation state. Taking cobalt as X plus minus 1 into 1 is charge of chloro, that is minus 1. Since there are 1 chloro, so minus 1 into 1 plus 0 into 5 because charge of amine is 0. Since there are 5 amine, we are multiplying 0 into 5 minus 2 because charge of Cl2 is minus 2 is equal to 0. X minus 3 is equal to 0. X is equal to 3. In the next example, there is no ionization sphere. This is neutral. Hence, tetracarbonyl nickel 0. Why 0? Because X oxidation state of nickel is unknown, so taken as X plus charge of carbonyl is 0. So 0 into 4 because there are 4 ligands, that is tetra is equal to 0. Hence X is equal to 0. So it is tetracarbonyl nickel 0. Next one. Try these examples. It's simpler. Now giving the answer for these questions. First, finding the oxidation state. Charge of sodium is plus 2 plus oxidation state of nickel is unknown. It's taken as X plus charge of cyano is minus 1. Since there are 4 cyano, we are multiplying minus 1 into 4, which is equal to 0. Then X is equal to 2. So writing the cation first and then the anion. Here we are writing sodium, then tetracyanonickelate 2. Nickelate because this is anion. Complex coordination sphere is anion, so we are writing nickelate. In the next example, oxidation state can be found out by taking copper as X plus amine 0 plus minus 2 because charge of SO4 is minus 2. SO4 2 minus, so minus 2, which is equal to 0. Then X is equal to 2. And writing the name of the coordination sphere, firstly we have to write the name of a cation and then the name of a anion. So writing the name of a cation first by naming the ligand first and then the central metal ion and then oxidation state. So tetraamine copper 2 sulfate. In the sixth example, here ionization sphere is given, that is ionization sphere is cation and then coordination sphere is anion. So writing the name as potassium hexafluoroplatinate, platinate because coordination sphere is anion. So it is negative, hence it becomes platinate. 4 because oxidation state is 2 plus X. Why 2 plus X? The charge of potassium is 2 here. So 2 plus X because X is unknown. That is charge oxidation state of platinum is unknown. Plus minus 1 into 6. Minus 1 is charge of fluoro. Minus 1 into 6, which is equal to 0. Then X is equal to 4. Hence, the name is written as potassium hexafluoroplatinate 4. Now, in this example, ionization sphere is cation and coordination sphere is anion. So, potassium tetracyanonickelate 2, oxidation state can be found out K2 plus. So, 2 plus X. X is oxidation state of nickel and plus minus 1 into 4. minus 1 into 4 because cyano has charge minus 1. Since there are 4 cyano, multiplying minus 1 into 4, which is equal to 0. Then x is equal to 2. In this example, coordination sphere is cation and ionization sphere is anion. Starting from alphabetical order, that is A, tetraamine diaqua cobalt 2 sulfate. Cobalt because coordination sphere is cation. Now finding the oxidation state, X plus X is cobalt here, plus charge of H2O is 0. So writing 0 plus charge of amine is 0. So 0 plus minus 2 here because sulfate as a 4 2 minus. So minus 2 which is equal to 0. X is equal to 2. Example. This is simpler. Dicyanoaurate 1. Oxidation state can be found on X plus minus 1 because cyano has charge minus 1 into 2 is equal to minus 1 because here minus 1 because this complex has minus charge here. So minus 1, hence X is equal to 1. In the next example, here ionization sphere is positive and coordination sphere is anion. And here writing the name as sodium pentacyano nitrosyl ferrate 3. Nitrosyl ferrate 3. Ferrate because coordination sphere is anion. Next oxidation state, charge of sodium is 2 plus ferrate is written as X plus charge of cyano is minus 1 into 5 plus 0. Nitrosyl, charge of nitrosyl is 0 which is equal to 0. Then X is equal to 3. Here there are two central metal ion, hence, and two complexes together in one coordination compound. So we are writing it as tetraamine platinum 2 tetrachloroplatinate 2. Now finding the oxidation state for both, taking platinum Pt as X plus we know that charge of amine is 0. So X plus 0 which is equal to 2. Because this complex has plus 2 charge, hence X is equal to 2. And then for this, X plus X is platinum minus 1 into 4 minus 1 because chloro has minus 1 charge multiplied by 4 because there are 4 chloro is equal to minus 2 because that complex has minus 2 charge and X is equal to 2.